to talk about piecewise defined or split functions. These are functions where different parts of the picture are occurring over different values. So on the right-hand side, these are my input values. On the left-hand side is my output. So if I were to graph this picture, I am starting out with values for x that are less than 0, and when I have values for x that are less than 0, my output is to take the opposite of those values. So that picture would look like this. And I have an open circle at 0 because it says do not include 0 in that. The next part of my picture says take a look at values between 0 and 2. I should have a closed circle at 0 and an open circle at 2. Well, from 0 to 2, at 0 my function is 0, at 1 my function is 1, at 2 my function is 4, and this has that parabolic shape. But it's going to fill in that circle that we previously closed at 0 and have an open circle at 2. The last part of my function is going to be to put values of x that are greater than 2 and equal to 2. And that means I'm going to have a closed circle, but my y values are going to be 5. So as I take a look at this picture, I can see that it is not a continuous function. There's a jump between this green section and the red section. The value actually goes up. However, I do notice that my domain is the set of all real numbers. As I travel from left to right across my picture, that issue where the green and the red come together is not a problem. Every value of x has a corresponding y value that goes with it. My range starts at 0 and goes upward. It's a value that's defined at 0, so that's a hard closed off bracket at 0. And because that blue part, the left-hand side, goes up and up and up forever, even though there's that little gap there, that gap is covered. So we're going to say it goes to positive infinity. Okay, let's try the same process in the other direction. Suppose I start with a picture of g of x, and I want to write an expression that represents that picture. So g of x in piecewise function form. I first notice that I'm defining it in two separate parts. I'm defining it first of all from the x values going from 0 up to 1. And I have a closed circle at 0, so that's going to be an or equal to, and just a regular less than at 1. And then I'm redefining again from 1 up to 2, and I am including both of those, hence the or equal to part of those expressions. So now I'm going to ask myself, can I figure out what the equation is from this part of the picture that goes from 0 to 1? Well, that looks like the expression every x value gives me a y value that's equal. The next piece looks very similar to it. It also looks like it's linear, but this piece is shifted to the right one, and we know our rules for transformations that if I want to take it and shift it to the right one, I'm actually going to write this like that. So now I have a picture of my function. And once again, we could figure out domain and range, do anything else we needed to with the function. Now we can see that our domain runs from 0 to 2 inclusive, and our range runs from 0 to 1 inclusive. And that is a split function.